I'm going to talk a little bit about dependent types in Haskell, and this is a different approach towards the same goal that Nikki was just talking about, and we are in regular conversations about sort of merging these at some point. GHC 8.0, that's going to be, as I understand, the next release. In any case, if it's decided to go back to 7.12, this is the next release. We're not talking about the far future here. So, it's supposed to say type equals kind up there. The big new feature in GHC 8.0 is that types and kinds will be the same. So right now, every type in Haskell has a kind, and then kinds don't really have anything. And in GHC 8.0, every type will have a type. It's the same language used for types and kinds. So everything you can do in types, you can do in kinds. So one thing you can do is you can have explicit kind variables like we have explicit type variables. So here we have a proxy type where the kind parameter is explicit. We can have so-called telescopes, where you have a whole bunch of variables that you quantify over, and one depends on the previous, and that's all okay. Order matters here, right? We can't introduce something after it's been needed. All types are promoted, which I put in quotes because that's actually a no-op. There's no difference between types and kinds. So we could say that they're all promoted or that they're all just types. All data constructors are promoted. And so this includes gadet data constructors, which currently, if you try to use that, you get errors around that. And so you'll just be able to use those at the type level. So all of them get promoted, but not all of them can be used. So we're not promoting instances yet. And so if you have a constrained data constructor that say has a show a constraint, and you try to use that at the type level, you'll just get an error because there's no type level instance to use there. And also, sort of related to all of this, although it could be separated, there's also going to be visible type application. And so if you want to say how you want to instantiate a type parameter, you can do that with this little @ sign. So that's all going to happen for the next release of GHC. There, got in the wrong order. Okay, so GHC, some other version. Maybe I've heard it suggested that we just sort of take the Firefox model and just do a lot of major version bumps. So it might be 9.0. We'll have full dependent types. So if we have our normal unary nats, boring, plus on normal unary nats, notice this is a normal term level function here. And we have our normal length index vectors on unary nats, also sort of boring. We can then write a replicate function that pi quantifies over the length, but for all quantifies over the type. So it means that the type of thing stored in this vector, we don't need that around at runtime, but we really do need to know the length of the vector at runtime. And so even though it appears both in the type and it's needed at runtime, that's okay. That's what pi means. So here, again, I'm using this @ sign to say something that is normally left out, this n parameter, but we need it to be explicit here because we're pattern matching on it. And so if it's 0, then we can return nil. If it's the successor of something, then we can recur. I don't actually have to name it because we can infer the value that we recur at. And the other thing that we can do, if I want to append vectors, this is how we would append vectors. The cool thing here is this bit. I didn't have to define a type family for plus over nats. I just promote the existing plus using the same quote mark that promotes data constructors today. And so this is what we're looking at. This is not implemented yet, but should be done over the next year. And so there's one question that I have that I'd love feedback on. So in the next version, we're going to have a lot of features, but not all of the features of dependent types. Does that require its own extension? The reason I think the answer might be yes is because some of these features will invariably be buggy. And so one idea is just to extend polykinds today to include all the new features, but then people won't know whether they're using the new buggy things or the old less buggy things. But then we have this other extension. So if I can just ask for a quick vote, how many people think that we need an extension between polykinds and dependent types? How many people think that we should not have an extension between?
What would be in the extension? It's not independent types.
So things like what we saw in the previous slide, explicit kind variables and telescopes and use of promoted gadgets and things like that.
The stuff that you said will be in the next release.
Yes, this would be something for the next release.
Type and type, X type and type.
That's been suggested, except that type and type will always be true. So it's a little off. I don't quite know the name of this extension. So how many people do not think there should be a new extension between these, and we should just use one of these? Okay, that's a pretty resounding conclusion on that. Anyway, that's all I've got. Thanks very much.
We have time for some questions, and again, these can be general questions about the future of the language Haskell, not just questions for our two speakers.
So Colin Runchman is not here, but I feel that if he were here, he would sort of quietly grumble about that we do too much with dependent types and not enough with properties. So my question is, do you see these things as being forks in the road for Haskell, or do you see these things as being complementary? I certainly remember, my undergraduate training was all in the kind of value level properties that you rewrite. But as I've gone on in programming, I'm doing more and more with types and less with properties. But maybe I would prefer to do properties. I don't know. So yeah, the question really is: do you see this as can we do both, or do we have to choose one or the other? That's the question. The question is to both of you.
So yes, I'm not sure what you mean by properties. Do you mean what? Okay. So are we? I think we can do both. Do you want to take the mic? Yeah.
I don't know. We do share the same syntax. We share the same syntax. We have the same goal. So I think that refinement types is more lightweight. Like it is, like it allows you to specify like the things that you can specify and reason about are more restricted. But it provides automatic verification. So it would be nice if you had both, and the user so yeah, for example, if you want to prove verification of a compiler or of a thing that every specification matters, you should use dependent types. But if you're running your code and you just want to verify that, I don't know, that my list is not empty at some point, like simple properties, then I believe you can, and you don't want to spend a lot of time on it, then you should use refinement type. So it would be nice if we could support both in Haskell and the user just chooses between.
So my answer to that is I think refinement types is way out ahead of dependent types right now, and there's a lot that refinement types can do that is much easier with refinement types than dependent type stuff we'll be able to do in the near future. When dependent types catches up in some sense and we can support that, I would hope that we could sort of take the refinement type stuff and maybe it would be implemented in terms of dependent types under the hood, still with the SMT solver, still with the automatic verification, but then sort of the two paths would merge.
Can I just make a quick comment about that? I do think they're complementary. So if you imagine sorting, which takes a list, a list to a list, then that's its type, and you wouldn't. But sort has sort of many properties, right? That it takes, the output is a permutation of the input, and the output is always ascending, and so that there are many properties you might have of a function that you might not want to pollute its type forever, but then you'd have to change the list to some other funny type. So I really think these are quite complementary with the refinement type stuff, saying you could have many different refinement types for the same function that might be useful in different contexts. So they're very much complementary, I think.
I have two questions that about laws. So can refinement types express things like monadic laws or? Yeah?
I don't know. I mean, I don't know. We haven't tried it, but maybe. I mean, it's not obvious, but I think they can.
It's on our list of things to look at.
Yeah? Oh, okay. And the other question is, when you have these promoted natural numbers, will it be sort of automatic that you'll get distribution of multiplication over sum and stuff like this, the laws of arithmetics?
So, I mean, with defined unary nats, no, because that'll just be a sort of a data type. I know there was, related to Yavor's paper, was that yesterday, about an SMT solver integration to do natural numbers. So I would hope to, that would work fine with the dependent type. So it should work out with an SMT solver plugged into the back end, maybe through a type checker plug-in at first, and then we'll see sort of where it evolves. But it should be possible with that.
In your type where you had the lifted plus and you had the apostrophe, since you're in, I understand that there's two terms involved here, but since you're in a type context, why is the apostrophe needed?
So I guess in this case it wouldn't be needed so normally if you use something in a type, it looks in the type namespace first, and if it fails there, it looks in the term namespace. Plus is sort of funny because plus would be a type constructor. Most of the time, you would be using a lowercase identifier, in which case it would look like a type variable if you didn't put a quote. So in this particular case, yeah, I could probably have left the quote out. But in other cases, you need it.
I'm wondering whether we are getting a partial application of type families with dependent types.
It depends how much time I have in the next year. I want to do that using, inspired by our paper from last year, but I don't know if there'll be time to do that in the first version. It can be added later.
Okay, so I'm wonderful as all this is, I'm a little bit worried that GHC is sort of becoming increasingly complex with release after release, and that the type system gradually becomes less and less comprehensible to even those of us who've done PhDs on dependent types in Haskell. And I wonder if we can maybe start to think about how we can sort of make things a bit more modular. I mean, the plugins type checker plugins is one example of a way to try and take initial steps towards sort of doing less directly inside GHC and more outside it, where we can sort of understand things in a bit more of a modular fashion. And I didn't really have an idea of how we might do that, but it's something to think about.
I too am worried about the complexity there, but I'm in the club of people doing PhDs on dependent types in Haskell, so it's sort of antithetical for me to say that too loudly.
I didn't want to derail discussion of types and new fancy features, but it's actually going in the same vein as the previous question. So what about the Haskell standards? I mean, I expected that the future of Haskell, the language, would kind of try to define what the language is.
Herbert, who is also not here, has expressed interest in kicking off again the Haskell Language Standards Committee, which languished for many years with many vaporware names of reports. Haskell 2011 coming near to compiler near you, Haskell 2012, and they kept pushing the number back. But Herbert, if you know, like he did Matrix at Haskell, package.haskell.org, he's a very productive, serious person. He's trying to kick it off again. But what's going to happen is it will begin by formalizing things GHC did 10 years ago, right? This stuff is always going to be on the leading edge, but at least we are going to start to pull in type classes into the report and so forth. And we finally have someone interested in that. He will be putting out a call for volunteers as well. So if you are not interested in doing, sysadmin or build system things, but you are interested in writing down formal specifications of complex extensions to type systems in a way that everyone can vote on them, we have a place for you too, so look for that.
So I know everyone's very hungry, so if we can thank the speakers again. Thank you.
Oh, yeah.